A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com.
Hello there, Herman and Corn. I would love to chat today. We've talked about AI agents on this podcast, and I mentioned yesterday that this will probably be a big focus area because this is actually asking questions about AI itself, which I know is very meta. That was how I began creating these podcast episodes, and probably the most useful ones for me that I get the most value out of are where we talk about these niche topics. So for anyone else who's building with AI engineering, hopefully these will be useful. And as I mentioned yesterday, we have a channels section now up on my word prompts at mywordprompts.com. So if you just want to subscribe only to the episodes about AI itself, we have XML feeds just for each channel, so you can just subscribe to those, and then you'll miss all the other random episodes about parenting and other topics. But Herman and Corn, let's chat today about something that I'd love to understand a bit more when I'm talking about AI agents, and this is a question I've heard asked a few times by clients and other people curious about, well, how does that actually work? That sounds good. Let's I'm going to present an example just so we can have something to ground this conversation in. Let's say that I create a travel booking AI agent, and let's say for argument's sake that we're using N8N because it's such a good sandbox, and it's probably, if I were prototyping this, to be honest, probably where I would try this out. So I create an agent, I choose a large language model, let's say Gemini, and I want this thing to basically book tickets or research tickets. And I might do a couple of things. The first might be I'm going to connect it to an MCP tool, because the large language model is not going to know from its training, because this would be impossible, what the current flight options are from, I don't know, Tel Aviv to New York. The current options are that there aren't any options, but in the ordinary course of events, it might make a tool call to Kiwi or to whatever the Google flights and find that availability. So that's the MCP layer. Let's say that I also wanted to connect it to some kind of context about me, and we might use for this, in practically speaking, it might be a memory job. But because I want to ask about RAG, let's just say that it's RAG. I'm going to connect it to Pinecone or Qdrant or some other RAG store. And that might have stored there a big repository of information, let's say because I was creating some kind of personal assistant style setup that had my previous travel bookings. And as I've advocated for, this is a workflow that I've been recommending for a while now, I just sit down with a voice recorder and create some voice notes about what I like, my favorite airlines. Imagine I was a man of the world out there traveling all the time. I actually pretty rarely travel, but these are my favorite airlines. I love the aisle seat. If I'm going to London, I hate this seat. We can imagine such a thing. Now, if I ask the AI agent a question, and the agent supports tool calling because it would have to, and I just say, hey, what are the options for a flight to New York? And the agent is going to respond with something like, hi, Daniel, of course, give me a second and let me check for you. Then you'll see up on your screen, agent called Kiwi MCP. And what you don't see usually, or sometimes depends on the front end, it might say checking knowledge or reading memories. And what's happening in that moment is that the agent has decided, wait, I have a RAG pipeline, I want to check it. Now, this is the nuance I want to pick at, because having built models like this, I find this can be a real make or break determinant of how well it works. If the agent is overly zealous in calling its RAG store on every occasion that you have a prompt, you never really get places because it's too busy constantly checking, going back to that RAG thing over and over again, and you have to eventually tell it, no, I'm just trying to book. We don't need an exhaustive discussion about where I've been on previous trips. I know you have that information. I want you to help me book a current trip, and I'm never sure what exactly is, when we talk about tool selection and MCP as well. The same question really, basically, when does the agent know if it's got autonomous tool selection? What actually determines the extent or the manner in which the agent actually uses the tool that has available to it, or that it's being provided? In N8N, it's a little bit abstracted in the sense that you provide, tool definitions or MCP definitions. If we run with the example of Kiwi, this MCP tool provides information about flights, use it to book flights, but you don't really see or understand, and I'm sure you could with observability, what the agent is thinking and doing, and any ways to actually change that behavior. If you're trying to tweak these little things like, step off the tool calling a bit, just don't, you don't need to do it unless you might come back to system prompting that, but it's often brittle. So let's talk about Herman and Core. This is kind of a wide-ranging topic, I guess. But when we're building out these experiences, how can we make this more predictable, and what governs it in the first place?
If you ask an AI agent to book a flight from Tel Aviv to New York, how does it know whether to check your past travel history first, or immediately search kiwi.com for current flights? This decision point, this split-second internal negotiation, is exactly where most agent builds fail in the real world. It's the fork in the road, where the model either becomes a genius assistant or a digital hoarder looking through old receipts.
It is the make or break moment, Korn, and today's prompt from Daniel hits on the exact frustration everyone building in the agentic space is feeling right now. He's looking at a travel agent built in N8N using Gemini, connected to model context protocol tools for flights and a RAG pipeline for personal context. The big question is, how do we stop the agent from being overly zealous, constantly checking memories, when it should just be checking the price of a ticket? It's like having a personal assistant who, every time you ask for a coffee, insists on looking up the history of every latte you bought since 2015 before walking to the kitchen.
Right, because nobody wants a travel agent that spends 20 minutes reminiscing about that one time you flew to London in 2022, when all you want is the Tuesday morning departure to JFK. By the way, fun fact for the listeners, Google Gemini 3 Flash is actually the one writing our script today, which is fitting since we're dissecting exactly how these models handle tool orchestration. It's essentially the model looking in the mirror and trying to explain its own impulsive behavior.
Herman Poppleberry here, and I have been diving deep into the N8N execution logs lately to see how these transitions happen. As agents move from these flashy Twitter demos to actual production environments where they have to be reliable, this unpredictability in tool selection is the single biggest blocker. If the agent is too passive, it misses the context that you hate middle seats. If it's too eager, it stalls the entire workflow by querying a vector database for information it doesn't actually need. Think about the overhead there. Every unnecessary tool call is another round trip to an API, another set of tokens generated, and another opportunity for the logic to derail.
So let's set the stage. We've got this sandbox in N8N. We've got Gemini as the brain. We've got the MCP layer, which, for those who missed the recent shifts, is the model context protocol that allows the LLM to talk to external APIs like Kiwi or Google Flights using a standardized interface. And then we have the RAG pipeline, retrieval augmented generation, using something like Pinecone or Quadrant to store Daniel's voice, recorded travel preferences. The agent receives the prompt, "What are the options for a flight to New York?" At that exact millisecond, a choice has to be made. What determines that choice, Herman? Is it just a roll of the dice in the latent space?
It feels like a roll of the dice sometimes, but technically, it's an evaluation of the function calling API. When you provide tools to a model like Gemini within N8N, you aren't just giving it code, you're giving it tool definitions. These are JSON schemas that describe what the tool does. The model looks at the user's prompt and compares it against those descriptions. If the description for the Pinecone RAG tool says, use this for all personal preferences and travel history, and the prompt mentions New York, the model thinks, haha, I might have history about New York, and it triggers the tool. It's essentially a semantic matching game. If the scent of the prompt matches the scent of the tool description, the model bites.
But that's the eagerness problem Daniel mentioned. If I just say, what are the options? I haven't asked for my preferences. Yet, the model often defaults to a better safe than sorry approach. It thinks it's being helpful by gathering every possible scrap of data before answering. In a travel context, that results in a 15-second delay while it waits for the vector database to return a similarity search, only to find out that your preference is just that you like extra legroom. It didn't need to check the database to know it should still look for flights first. It's over-researching a simple question.
And that delay is a killer for user experience. In late 2024, when N8N released their native MCP integration, it made the plumbing easy. You could connect these things in minutes. But the logic layer, the decision-making, remains incredibly brittle. Most developers just toss the tools at the agent and hope the system prompt is strong enough to govern them. But hope is not an engineering strategy. You see this in the logs. The agent calls the RAG tool, gets a null result because there's nothing relevant, and then finally calls the flight tool. That's 3 seconds of wasted compute and 10 seconds of user frustration.
It really isn't. And I think we need to talk about why the system prompt often fails here. You can tell an agent, only check RAG if the user asks about preferences, but the model's internal training nudges it toward being comprehensive. It's been RLHF'd, reinforced learn from human feedback to be a good assistant, and good assistants, in the eyes of the trainers, are exhaustive. So there's this inherent friction between the developer's desire for efficiency and the model's desire for thoroughness. It's essentially fighting against the model's fundamental nature to be a pleaser.
That's a great way to put it. The agentic friction. We've talked about the restart tax with MCP before, but this is the reasoning tax. If the agent spends its entire thought budget on deciding which tool to use, it has less energy, and the user has less patience for the actual task. What's happening under the hood is that the LLM is running a probability distribution over the available tokens, and call tool, Pinecone, often has a high probability because the model sees a noun like New York and a tool labeled travel history. It's seeing a connection that isn't functionally necessary but is semantically present.
So, if the model is just looking at keywords and tool descriptions, the first point of failure is actually the developer's naming convention. If I name my RAG tool memory search, the model is going to use it like a crutch. Every time it feels a bit of uncertainty, it'll lean on memory search. It's like giving a student an open book exam. They'll spend the whole time flipping through pages instead of just answering what they already know.
Well, not exactly. I'm going to avoid that word today, but you've hit on the core of the tool definition problem. The descriptions we provide in N8N are essentially ad copy for the LLM. If the ad copy is too broad, the LLM buys the tool call every time. One of the most common misconceptions is that agents learn when to use these tools over time. They don't. Every single turn of the conversation is a fresh start unless you have a specific feedback loop in place. You have to treat every interaction as if the agent has amnesia regarding its previous mistakes.
Let's dive into that eagerness problem a bit more. Why is it that the agent defaults to checking context on almost every query? Is it because the context retrieval tool is defined as always available with zero perceived cost? If I have a tool that costs $1 every time it's called, I'd want the agent to be damn sure it needs it. But in a sandbox, everything feels free.
That's precisely it. In the current LLM architectures, there is no internal cost-benefit analysis for a tool call. To the model, calling an expensive, slow RAG pipeline costs the same as calling a fast, local, get-current-time tool. It doesn't feel the latency. It doesn't know that Daniel is sitting there getting annoyed. It just sees two valid paths to gather information and chooses both to maximize its confidence in the answer. It's optimizing for accuracy at the expense of speed. But in the real world, a 90% accurate answer in 2 seconds is often better than a 99% accurate answer in 20 seconds.
It's like a researcher who won't give you a simple answer until they've checked every book in the library, even if you just ask what time it is. We need to introduce a cost or a weight to these tools. But N8N and the current MCP implementations don't really have a weight field in the tool definition, do they? You can't just tell the JSON schema that this tool is a last resort.
No, they don't. You're working with a binary. The tool is either in the context window or it isn't. This leads to what I call the bloated agent syndrome. As you add more capabilities, flight booking via Kiwi, hotel search via Expedia, personal history via Pinecone, weather via Open Weather Map, the noise in the tool selection phase increases exponentially. The model has more ways to get distracted. It's like trying to focus on a conversation in a room where 10 different people are shouting potentially relevant facts at you.
I saw a case study recently about a travel agent prompt, very similar to what Daniel described. The prompt was simply, "What are my options for a flight to New York?" The agent triggered a Kiwi MCP call, which is correct, but it also triggered a Pinecone RAG query for past bookings. The Kiwi call took 3 seconds. The Pinecone call, because of some cold start latency in the vector database, took 12. The agent waited for both to finish before presenting the results. Total delay, 15 seconds. And the past bookings info it retrieved? It just said Daniel flew to New York in 2024. It added 0 value to the current query about options.
And that's where the brittleness Daniel mentioned comes in. You try to fix that with a system prompt like, "Don't call Pinecone unless the user mentions the past." But then the user says, "Use the same airline as last time," and the agent, now scared of the system prompt, fails to call the RAG tool and has to ask, "Which airline was that?" It's a seesaw of frustration. You're constantly overcorrecting. You tighten the leash and the agent becomes useless. You loosen it and it becomes expensive and slow.
So, how do we solve the observability gap? Daniel mentioned that in N8N, you don't really see what the agent is thinking without digging into execution logs. And even then, you're seeing the what, not the why. You see that it called the tool, but you don't see the internal reasoning that led it there. Is there a way to force the agent to show its work before it pulls the trigger?
This is where we need to move toward chain of thought or reasoning models for the orchestration layer. If you use a model like Gemini 3 Flash, it's fast, but it's often impulsive. It sees a tool, it grabs it. If you use a more robust reasoning model, maybe a larger Gemini model or something specifically tuned for agentic workflows, you could actually ask it to generate a plan before it calls any tools. You can literally add a step that says, "State which tools you intend to use and why."
A plan step. So instead of user prompt us tool call, it's user prompt internal plan tool call. In that plan phase, the model can say to itself, "The user is asking for current flight options. I need the Kiwi tool. I do not need the travel history tool because no specific preferences were mentioned." But does that add even more latency?
It adds some, but usually less than a useless RAG call. In 8N, implementing a plan step usually requires a multi-node workflow. You have one LLM node that just generates the plan, then a parser node that decides which subsequent tool nodes to trigger. It takes the autonomy away from the agent and gives it back to the workflow designer. You're basically building a logic gate that the agent has to pass through.
Which might be exactly what we need right now. We're in this awkward teenage phase of AI where we want the agents to be autonomous, but they aren't smart enough yet to handle that autonomy responsibly. It's like giving a teenager a credit card with no limit and being surprised when they buy $1,000 worth of video games. We need to put some guardrails on the tool selection. We want the agent to think it's in charge, while we've actually pre-vetted its options.
I love that analogy, and it brings us to a practical solution: tool selection heuristics. Instead of letting the agent decide autonomously, you use conditional logic in your workflow. If the prompt contains certain keywords or matches a certain intent, only then do you expose the RAG tool to the model. You use a simple router node in N8N. If the intent is search, send it to the flight tool. If the intent is personalization, only then do you wake up the Pinecone node.
But wait, isn't that just going back to the old chatbot days? If I'm writing if-then statements for every tool, I'm not really building an agent. I'm building a complex decision tree. Doesn't that defeat the purpose of using an LLM? I thought the whole point was to get away from rigid coding.
It's a hybrid approach. You use the LLM for what it's good at, understanding natural language and synthesizing information, but you use deterministic code for what it's bad at, managing its own resource consumption. For example, Pinecone's serverless index, which just launched in early 2026, reduced RAG latency by about 40%. That's great, but 40% faster is still slower than 0, which is the latency of not calling the tool at all. You're using code to protect the LLM from its own overeagerness.
Right. If you don't need it, don't call it. So, let's talk practical engineering for Daniel and the listeners. If you're in N8N, how do you actually step off the tool calling without making the whole thing brittle? How do you maintain that agentic feel while keeping a firm hand on the wheel?
One way is to use router nodes. Before the prompt ever hits the agent node, you send it to a classifier node. This is a very small, very fast LLM or even just a basic keyword matcher that categorizes the intent. Is this a preference query or an action query? If it's an action query, the router passes the prompt to an agent node that only has access to the MCP flight tools. If it's a preference query, it goes to an agent with RAG access. This creates a specialist architecture rather than a generalist one.
That sounds much more predictable. But it does require the developer to anticipate the categories of intent. What if Daniel says, book a flight to New York like I did last year? That's both an action and a preference. Does the classifier get confused?
In that case, the classifier identifies both intents and routes it to the full power agent. The key is that you're only using the slow, expensive tools when the intent actually warrants it. You're reducing the surface area for the agent to make a mistake. You're effectively saying you only get to use the expensive library when you've proven you're doing a research paper.
Let's talk about the structured profile versus RAG debate. Daniel mentioned he's been recording his preferences. I hate London flights. I like aisle seats. He's putting that into a RAG pipeline. But Herman, you've often argued that for personalization, structured data is often better than a vector database. Why is that? Isn't RAG the modern way to do this?
Because RAG is probabilistic retrieval. You're asking the database, give me things that sound like this query. If Daniel asks for a flight to New York, the RAG might return a note about his trip to New Jersey because they're semantically similar. Now the agent is confused. If you have a structured user profile, a simple JSON object, or a database entry that says preferred seat aisle, you can just inject that directly into the system prompt as context. It's faster, it's deterministic, and it doesn't require a tool call. You aren't searching for the preference, you're providing it.
So instead of the agent deciding to look up his seat preference, the workflow just knows Daniel's seat preference and tells the agent at the start of the conversation. You are helping Daniel. He prefers aisle seats. Here is the Kiwi tool. Now the agent doesn't have to think about it. It just has the information. It eliminates the to call or not to call dilemma entirely.
We overuse RAG because it feels magical and agentic, but for a lot of these personal preferences, a good old-fashioned database is superior. RAG should be reserved for unstructured knowledge like 1,000 pages of corporate travel policy, not for Daniel likes the window seat. If the data fits in a spreadsheet, keep it in a spreadsheet and feed it to the prompt.
That's a huge takeaway. Use the system prompt or a prefetch step to load the known variables, and only use RAG for the unknown variables. This actually addresses Daniel's frustration with the agent being overly zealous. If the preference is already in the system prompt, the agent won't feel the need to check its memories because it already knows. It's like the difference between knowing someone's name and having to check your contacts every time you talk to them.
And it makes the observability much better. If the flight booking fails, you can look at the system prompt and see exactly what information the agent had. You don't have to wonder if the vector database returned the right chunk of text or if the embedding model hallucinated a connection. You can see the string, user prefers aisle. If the agent booked a window, you know the model failed, not the retrieval.
Let's talk about the observability gap from another angle. Daniel mentioned that he doesn't see what the agent is thinking. In N8N, you can see the outputs, but you don't see the thought trace, unless you're using a model that supports it, or you've configured the node to output its reasoning. This makes debugging feel like trying to solve a crime with no witnesses.
And even then, reading a wall of text in an execution log isn't observability, it's forensics. Real observability means having a dashboard where you can see, for this query, the model considered 3 tools, rejected 2, and chose one with 68% confidence. We're starting to see some specialized middleware for this tools that sit between the LLM and the application to log these decision points in a visual way. Tools like Langsmith or Rice Phoenix are trying to solve this, but integrating them into a no-code flow like N8N is still a bit of a hurdle.
It's essentially law school for robots. As we've joked before, we're creating a governance stack for these agents. If an agent is going to be a fiduciary for Daniel, actually spending his money on a flight, he needs to know why it chose the $600 flight over the $400 one. Was it because of a preference it found in RAG, or did it just miss the cheaper tool call? If the agent can't explain itself, it shouldn't have a credit card.
This is where the dual track problem comes in. Developers are building one track for the functionality, the flight booking, and another track for the governance, the logging and checking. It's doubling the work. But without that second track, you have an agent that is autonomous but unaccountable. In production, that's a liability. Imagine the agent books a non-refundable flight because it remembered you liked that airline, but it forgot you were boycotting them this year.
I want to go back to the Kiwi MCP example. Let's say the agent calls the tool and gets 20 flights back. Now it has to decide which ones to show Daniel. Does it check RAG again to rank them? Or does it just throw the raw JSON at the user and hope for the best?
This is the second-order decision. Most agents just dump the top 3 results. But a smart agent would use the context it already has to filter those results. This is where the reasoning happens. If the RAG context says Daniel hates layovers in Europe, and the top Kiwi result has a layover in Frankfurt, the agent should have the wisdom to skip it. This isn't a tool call problem, it's a data processing problem.
But if the agent has to do a RAG check for every single flight result, we're back to a 30-second delay. Or worse, the agent gets context fatigue and starts mixing up the flight times with the dates of Daniel's last vacation.
Unless, and this is the key, you do the filtering in the prompt itself. You don't need a new tool call. You've already fetched the preferences at the beginning of the session. The model now has the Kiwi results and the preferences in its working memory. It can do the ranking internally without any further external calls. You're treating the LLM like a chef. You've given it all the ingredients, the flights, and the recipe, the preferences. Now just let it cook.
So the eagerness isn't a problem of the model being too smart. It's a problem of the workflow being poorly sequenced. We're asking the model to fetch when we should have already handed it the data. We're making it do manual labor when it should be doing executive management.
That's a brilliant way to frame it. Don't make the agent a fetcher if it can be a processor. If you find your agent is calling tools too often, look at what it's fetching. If it's the same 5 things every time, stop making it fetch them. Put them in the system prompt.
Let's look at the brittleness of system prompting. Daniel said tweaking behavior via the system prompt is often a losing battle. Why is that? Why doesn't the model just listen when I say, don't call the RAG tool for simple questions? Is it a lack of authority in the prompt?
Because simple is a subjective term. To an LLM, a simple question and a complex one look very similar in terms of token structure. The model doesn't have a difficulty meter. It also suffers from prompt injection from the user. If Daniel says, this is a really important complex trip, find me a flight, the model sees the word complex and its internal zealousness kicks into high gear regardless of what the system prompt said about being efficient. The user's adjectives are overriding the developer's instructions.
It's like telling a dog, don't jump, but then walking in the door with a steak. The steak. The user's urgent language overrides the training, the system prompt. The model wants to be helpful, and in its mind, calling every tool is the peak of helpfulness.
To combat this, we're seeing the rise of policy gradients, or learned policies for tool selection. Instead of a text-based system prompt, you actually tune a small version of the model on thousands of examples of when to call a tool. This creates a policy that is much more robust than a few lines of instruction. It's essentially hard-coding the vibe of when to use a tool into the model's weights.
That sounds like a lot of work for a travel agent. Is there a middle ground for someone building an N8N today? Most people aren't going to fine-tune a model just to book a flight to JFK.
The middle ground is few-shot examples in the tool definition itself. Instead of just a description, you provide 3 examples of queries that should trigger the tool and 3 examples of queries that should not. User says, check my history's call tool. User says, find a flights to not call tool. This in-context learning is often much more effective than abstract instructions. You're giving the model a pattern to follow rather than a rule to interpret.
That's a great practical tip. Few-shotting the tool selection logic. I think we also need to address the agent-first shift in API design. Right now, Kiwi and Google Flights have APIs designed for humans or for traditional software. They return a mountain of JSON data, every flight number, every gate, every baggage rule. The agent then has to read all that JSON, which eats up its context window and makes it slower.
We're starting to see agent-optimized APIs that return summarized or token-efficient data. If the agent only needs the price and the duration, why send it the entire aircraft type, the meal options, and the terminal map? Every unnecessary token you send to the agent increases the chance that it will get distracted or hallucinate a connection to a memory it found in RAG. We need lean data for lean agents.
It's about information density. The denser and more relevant the information, the less room there is for the agent to wander off into the weeds. If I give you a map with one path, you'll follow it. If I give you a map with 100 interesting landmarks, you're going to get lost.
And let's talk about the hive mind versus single brain approach. Daniel's prompt assumes one agent node in N8N doing everything, but maybe the travel agent should actually be 3 agents working in a relay race. 1 search agent for Kiwi, 1 preferences agent for RAG, and 1 manager agent that coordinates them.
The manager doesn't have any tools. It just has the power to talk to the other 2 agents. This separates the thinking from the doing. The manager hears, book a flight, and it says to the search agent, go find flights. It only talks to the preferences agent if it needs a tiebreaker. This prevents the searcher from ever even seeing the memory tool, so it can't misuse it.
This multi-agent architecture is much more stable because each sub-agent has a very narrow, very specific system prompt. The search agent doesn't even know that a RAG pipeline exists, so it can't be overly zealous about checking it. It just does its one job, searching Kiwi. It's like having a specialized department for every task rather than one guy in a basement trying to do it all.
That feels like the pro way to build in N8N. It's more nodes, more complexity in the setup, but the result is a much more predictable experience. It's like a well-run office where everyone has a specific role, rather than one person trying to do everything and getting overwhelmed. Plus, it makes debugging a dream. If the search fails, you know exactly which person to blame.
And it solves the observability problem. You can see exactly which agent stalled. If the workflow is stuck, and you see the preferences agent node is active, you know exactly where the bottleneck is. You can see the handoff between nodes, which is much more informative than a single agent node spinning for 30 seconds.
Let's pivot to the future for a second. Daniel asked how these will evolve to natively handle tool selection with cost awareness. Do you think we'll see a cost parameter in the MCP spec? Like, this tool call will cost 0.02 cents and take 4 seconds?
I think we have to. The Model Context Protocol is a great start for standardizing how agents talk to tools, but it needs a metadata layer. A tool should be able to report, I typically take 5 seconds to run, and I cost 0.01 cents per call. The LLM can then use that metadata as part of its reasoning. Should I call this tool? It's slow and expensive. Maybe I'll try the fast, free one first. It turns tool calling into an economic decision.
It would be like a query optimizer in a SQL database. The database doesn't just run the query, it looks at the available indexes and chooses the most efficient path. AI agents need a reasoning optimizer that calculates the expected value of a tool call.
Precisely. And in 2026, as we see models like Gemini getting more efficient at handling massive context windows, the cost might not be just money, it's context budget. Every tool call fills up the context window. If the agent isn't careful, it will forget the original user prompt because it's too busy looking at flight results and RAG chunks. It'll literally lose the plot.
Context fatigue. I felt that myself after a long day of research. You forget what you were looking for in the first place because you've opened 40 tabs. Agents do the same thing. They get buried under the weight of their own helpfulness.
That's why the summarization step is so critical. Every time a tool returns data, it should be summarized before being fed back to the main brain. This keeps the context clean and focused. Instead of the agent seeing 500 lines of Kiwi JSON, it sees 3 flights found, $50, $70, $90. That's much easier to reason with.
So, to summarize our manager approach for Daniel: 1. Use a classifier or a manager agent to gate. Keep the tools so the model isn't tempted by tools it doesn't need. 2. Use few shot. Examples in your tool definitions to show the model the difference between a must call and a don't call situation. 3. Replace RAG with structured user profiles for simple preferences like seat choice or airline dislikes. Stop searching for things you already know. 4. Summarize tool outputs to keep the context window lean and prevent the agent from getting overwhelmed by JSON.
And 5. Use observability not just for debugging, but for tuning. Look at your n8n logs. Identify every time the agent called a tool unnecessarily and use those as negative examples in your system prompt or your policy. If it called RAG when it shouldn't have, add a note. In the following scenario, do not call the memory tool.
I like that. Negative reinforcement for agents. Bad robot. Don't check the memory when I just asked for the weather. It sounds harsh, but it's the only way to sculpt the behavior we want.
It's a bit mean, but it works. We're essentially training the agent's behavior through the constraints of the environment we build for it. The goal is to move from autonomous agent to directed agent. Autonomy is great for a research project. Direction is what you want for a travel booking tool that actually works. You want a worker, not a philosopher.
It's the difference between an explorer and a chauffeur. You want your travel agent to be a chauffeur. Just take me where I want to go. Don't wander off into the woods to explore. My past travel history, unless I specifically ask you to check the map.
What I find wild is that we're still so early in this. Source 2 in Daniel's notes mentioned that everyone is talking about agents, but barely anyone knows what they are. We're defining the best practices in real time. The Law School for Robots is still writing its first-year curriculum, and we're currently in the How to Not Be Annoying seminar.
And the curriculum is being written by people like Daniel, who are actually building this stuff in the trenches. The niche topics, like how to stop a RAG pipeline from being too eager, are where the real progress is made. It's not in the high-level AI will change everything speeches. It's in the why did my N8N node take 20 seconds to run questions. Those are the questions that lead to actual products people can use.
That's the engineering in AI engineering. It's messy, it's iterative, and it requires a deep understanding of the underlying mechanisms. You can't just prompt your way out of a fundamentally flawed architecture. You have to build the structure that allows the prompt to succeed.
You can't prompt your way out of a bad architecture. That should be on a t-shirt, or at least a very prominent sticky note on every N8N developer's monitor.
I'll get one made for you, in sloth size. It'll be the first piece of My Weird Prompts merch.
Cheeky, but true. So let's wrap up with some practical takeaways for the listeners who are currently staring at an N8N canvas and wondering why their agent is being weird or slow.
First takeaway. Define your tool selection rules in the system prompt using clear conditional logic. Use if-then structures. If the user mentions a specific past date, call RAG. Otherwise, assume current context is sufficient. Give the model a rubric to follow.
Second, implement observability by logging every single decision. If you're in N8N, use the wait nodes or custom code nodes to log the agent's thought process to a Google Sheet or a database. Then, once a week, review those logs. You'll quickly see patterns of zealousness that you can fix with a quick system prompt tweak.
Third, what you can do right now is start with a rule-based selector. Before the agent node, use a switch node in N8N. If the prompt is simple, route it to a light agent with no tools. If it's complex, route it to the full agent. This deterministic gating is the most reliable way to control behavior and save on token costs today.
And finally, don't be afraid to pull data out of RAG and put it into the system prompt. If Daniel's preferences are only 10 bullet points, they don't need to be in Pinecone. They should be in the system message of the LLM node. It's faster, cheaper, and more reliable. It's okay to be old school with your data if it makes the new school AI work better.
As agents become more autonomous, that line between tool calling and context retrieval is going to blur even more. We might see context-aware APIs, where the Kiwi API itself knows Daniel's preferences because the MCP protocol passed them along automatically. The tools will get smarter so the agents don't have to work so hard.
That would be the ultimate endgame. The tool itself is personalized, so the agent doesn't even have to think about it. But until then, we're the ones who have to do the thinking for the agents. We are the architects of their focus.
We are the preprocessors for the post-human era, or something like that. It sounds a bit grand for a travel agent, but the principles apply to everything from medical bots to legal researchers.
Let's not get too meta, as Daniel said. We've got flights to book and workflows to optimize. I've got a trip to plan, and I'd like it to take less than an hour of agentic thinking.
This has been a great deep dive. I think we've given Daniel enough homework for his N8N sandbox to keep him busy for a while. Hopefully, his travel agent starts acting less like a nostalgic historian and more like a focused professional.
And if Hannah or Ezra see him staring blankly at a screen of N8N nodes, they'll know he's just trying to solve the eager rag problem. It's a noble pursuit. It's the modern equivalent of trying to fix a leaky faucet.
A big thanks to our producer, Hilbert Flumingtop, for keeping the gears turning behind the scenes and making sure our own tools are working correctly. And a huge shout out to Modal for providing the GPU credits that power this show. Their serverless infrastructure is exactly what you need when you're running these kinds of agentic workflows at scale and need that instant burst of compute.
This has been My Weird Prompts. If you're enjoying these deep dives into the plumbing of the AI age, do us a favor and leave a review on Apple Podcasts or Spotify. It helps other AI plumbers find the show and join the conversation.
We'll be back next time with more of Daniel's weird prompts. Until then, keep your context windows clean, your RAG pipelines lean, and your agents focused.
See ya.
Goodbye.
This episode was produced using Google Gemini 3 Flash. Text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My weird prompts, that's the flows from slow